switch the stream to me? Camera?
Hi, welcome to Science on Tap this evening. I just wanted to make a quick announcement to our online audience that we are going to be starting 5 to 10 minutes late this evening. So look for our stream to begin 5 to 10 minutes late this evening. Thank you very much. Have a great evening and enjoy the presentation.
Okay. Hello, good evening, everyone. Welcome to Science on Tap. Thanks for coming. My name is Carol Warden. I work at the UW Trout Lake Station. Science on Tap is an example of the Wisconsin idea, an idea conceived in 1905 that the boundaries of the university are the boundaries of the state. At Science on Tap, you won't get a lecture, but have an opportunity to learn and ask questions about different topics. And I'd like to remind us all of our partners, Monaco Public Library, Lakeland Badger Chapter of the UW Alumni Association, UW Trout Lake Station, Kemp Natural Resources Station, and the Monaco Brewing Company. And Science on Tap is funded through the Brittingham Fund at the University of Wisconsin-Madison. And there are 4 ways to watch. You can come to the brewery like you have here. We live stream at the Monaco Public Library, and you can watch there. And through that live stream, you can go to our website and watch live anywhere from the comfort of your own living room if you'd like. And then we archive them, and you can watch later. You can watch events later as well if you missed it the first time. And we've been meaning to ask you all, and since we have such a big crowd, I just wanted to take a quick show of hands poll on how you learn about Science on Tap. Who learns it from an email that they receive? All right, a fair amount. Who learns it from posters that they see throughout the community? Library? Okay. And who learns it from going to our website? Few. All right. Anything else outstanding? That might be friends, Facebook. Okay. Okay. Excellent. All right, well, our next Science on Tap is February 5th, and our speaker will be Dan Preston, and we will be talking about conservation of our freshwater ecosystems. Tonight, we have Dr. Greg Nemeth. He's a professor at UW-Madison's La Follette School of Public Affairs. Greg grew up in Montreal, Canada, Quebec. He spent his summers in northern Ontario, and northern Wisconsin reminds him a lot of that area, especially the water clarity in some of our precious lakes. Greg studied geography as an undergrad and took a course in energy and one on climate change. He worked in the industry after that, and then at a startup and a think tank in Silicon Valley, and it became very clear to him that one of the most innovative regions on the planet, where so much talent and other resources were going into information technology, consumer products, and health, and so little of that was going into energy. So he actually did a study on that, and many indicators such as patents, people, and research funding were lower in the field of energy by an order of magnitude. So that led Greg to apply to grad school at Berkeley, where a professor had studied some of this underinvestment. He's still working on that question now. How do we design public policy to stimulate innovative, low-carbon technology? So we have a trivia question for you, per the usual. So a little anecdote. Greg was teaching his course on international policy that usually meets on Tuesdays at 1:30. But he had a meeting out of town, so he asked his class if they could meet on that Thursday at 1:30, and they all agreed. So Thursday came, and he got to his class just on time, and he went through his usual routine of putting out the class agenda on the board and checking his notes before starting his lecture. And a few lines in, he noticed the students looked very confused. So what did he realize? He had the right time, but the wrong classroom. The professor who was supposed to teach that class was late. He was going to be really late for his own class, or all of the above. Yes. But you made it to your class on the other side of campus. Yes, eventually. So thanks again to Greg Nemeth.
Well, thanks, Carol, for such a generous introduction, and it's great to be here in Monaco. I've been traveling around quite a bit, talking about this book, and I've done this talk in Beijing and Tokyo a couple weeks ago. I've done it in Saudi Arabia, but I've never done it in a place where I got to ski a couple hours before doing the talk, and that was such a great experience with my daughter Pamina over here today. So it's so beautiful up here, and it's great to be here. Yeah. So as Carol made that introduction, I work on how to stimulate innovation in low carbon technology, and it really came from yeah, my experience in Silicon Valley and basically seeing a lot of talent there and not a lot of effort in this area. And so um, one of the things that I talk about in the classes I teach on energy and environmental policy is to start to make the case about why it's so hard to come up with new technologies or do innovation in energy. And maybe you could think why it's much easier to do it in terms of inventing new social networking or other technologies. One of the reasons it's hard is that we disagree on what we want out of an energy system. And I make the case in my classes that we want energy that's cheap, that's clean, and that's reliable. And no one would quibble with having an energy system that could do all three. The problem is that those are often in contention with each other, and there are trade-offs that are difficult to make. And so some people will argue we need really reliable energy, some people are really focused on cost, and others will be focused on environmental impact. So that's one thing that makes energy policy and innovation hard, is we don't agree on exactly what we want. The second thing that makes it hard, and I'm not sure that everyone appreciates this, is that the energy system is really slow to change. And if you look historically, which I often do to elucidate policy choices, transitions from a major energy carrier, like going from 150 years ago where wood was the dominant energy carrier, to the First World War where coal was the dominant energy carrier, to the second half of the 20th century where oil was the dominant energy carrier, those took 50, 60, 70 years to go from one to the other. And so if we're talking about transitioning to some system that's cheap, that's clean and reliable, we want to do that in a way that's faster, that doesn't take us to 2090 by the time we have this system available to us. So that's the second thing that makes things hard. Stuff changes slowly. And third, if we're thinking about climate change, there's a really big difference between putting CO2 in the atmosphere and putting traditional pollutants into the atmosphere like sulfur or like nitrogen, is those get rained out of the atmosphere in days to weeks, whereas when you put CO2 in the atmosphere, it stays there for a really long time, and 100 years is a good kind of average time to use. And so that also makes things slow. So one thing I realized as I was making these points more elaborately in classes is that I was doing a really good job of getting students to understand them, and thus to be really discouraged that we could ever do anything to the system. And that was exactly the opposite of what I wanted to be doing with my teaching. But it was also not how I felt personally, and not how I felt my colleagues felt about making changes and stimulating innovation in energy. And so I started to work on a list of reasons, just trying to be explicit. Why do I keep getting up in the morning and working on this stuff? And I started to come up with a longer list of reasons to be optimistic that we can actually change our energy system to something that the people will benefit from in a bigger way. And a few of those reasons are, one, we can think about examples of societies that use low energy or use very efficient energy and have really high standards of living, high education, high health outcomes, high incomes. So those examples abound, and those are good examples to use. Second, we can think of co-benefits. So we may be thinking about dealing with something like climate change that's global, takes a whole century to really deal with. But in the meantime, you might have employment benefits. You certainly will have air quality impacts that are near-term and local. And so if you can combine near-term and local with global and long-term, that's a pretty nice combination too. And that makes me optimistic that we'll find motivation. And then underlying a whole bunch of these reasons is the fact that even though we've had 30 years of politicians mostly dithering on climate change and not really getting much done, in the background, technology has been improving. Things are getting more efficient. We have LED lights that are cheap and available now that weren't like that 10 years ago. We've got really important technologies like solar power, like electric vehicles, and like wind power that have dropped in cost by significant amounts over the last 10 or 15 years. And that just makes doing something with the energy system much, much easier. And so that was kind of one of the biggest sources of optimism that I come away with. And it also leads me to focus on understanding this and what I call innovation or technological change. So what is it that makes wind power, solar power, electric vehicles, LED light bulbs, and a host of other technologies improve over time? And so my perspective is that we can do a better job of designing policy and stimulating investment in technologies that we'll need in the future by understanding how technologies have developed in the past, and especially technologies that have developed in the past that have done so successfully. And there's no question that solar photovoltaics has been a successful technology. And that led me to do something I'd never done before, which is write a book. And a couple years ago, when I started this project, I started calling up people that had written books before to get advice about how to do it. And I talked to a mentor of mine, one of the smartest people I've ever met. He was an Austrian guy, and I started this conversation, and I got very excited. I was like, yeah, I'm going to go all over the world and interview people and talk about solar and do a whole story of it and put it in a book, and what do you think? And he was like, Gregory, nobody reads books anymore. And so I was really taken aback by that. And I had to really, but it was discouraging. But on the other hand, it made me think, like, yeah, what's the point of doing that? It is a lot of work, and people don't. Not everybody reads a book. So I started to think about what it is that a book would do that the other stuff I've done, writing papers or doing data analysis, maybe it was missing. And I think the thing that I thought was that all along the way, and I've been studying the cost of solar for 15 years, there were variables or factors or things that were just hard to measure that weren't being included in research reports or there wasn't data on. And so what I really wanted to do was just go around and interview people and see what was in people's heads, what was their interpretation of how things worked in their country or in their company. And so that's what I did. I talked to 75 people in 18 countries about putting this story together, about what it made, how solar got to where it is today. And one of the things that I start out with in the book and in talks I give is to make the point that a lot of people don't get, understandably, is that in sunny places today, solar energy is the cheapest way to make electricity. It's regardless of the cleanliness of it or the environmental benefits, it's the economically most competitive way to do it in a sunny place. And even in places more northerly or with snow and clouds like around here, it is becoming competitive as well. And we're now seeing large solar projects go in Wisconsin now, which a couple of years ago would have been considered crazy. So solar has come a long way. And so one of the things that I wanted to put together is to say, how did it get there? So not so much say what happens now that we have cheap solar energy, but what was it that got us there? And so that's what the book story was really about, and that's what all those interviews tried to do. And maybe just to summarize it, one of the main takeaways, if you look at the 60 or 70 years progression of solar energy, which I think is what you really need to look at, no one country did it. It was a sequence of 5 countries. It was the US, Japan, Germany, Australia, and China. Each country that was the leader in solar, which US was for quite a while, for 20 or 30 years, gave up its lead, and some other country came along and picked it up and brought it to the next level, and then another country took it. No company that ever was the biggest solar company in the world ever lasted that way for more than a couple of years. It changed hands. And each country that did something, and those are the 5 key countries, really contributed something distinct. They really used what's called their national innovation system, the way their culture works, how people are educated, the way risk is managed, how companies start up, whether they're big or small or startups. Each of them added something a little bit different, and when you put it all together, that's what led to the technology that we have today. So there really was this progression, and no one country did it. There were these flows of knowledge that moved from one country to another. Sometimes it was in machines that were made in one country and then moved to another country. Often it was people that worked in one country and then started working in another country, for example. And then the goods themselves, solar panels, moved around the world as well. And the finance and the investment for it really did move that way as well. And so that's kind of the second point, is these international flows. And then finally, what I really wanted to do in this book is not just tell the solar story, but say, what do we know about other technologies? What do we learn about other technologies that we could take forward? And the first thing I would say with that is that whatever we do for other technologies, we have to do it much more quickly. So solar was a big success, but it happened really slowly. It took 70 years from the first commercial solar power plant, which was on a satellite in the 1950s, to the way we're talking about cheap solar today. So if we're thinking about electric vehicles progressing or other technologies we might need, we have to find ways to accelerate that innovation. That's a lot of the work that I'm doing right now. So I really want to move on to your questions, but just to kind of illustrate a few points along the way in the solar story, just to start with where it goes back to, one of the most important aspects of solar was scientific understanding, like learning how light interacts with atoms and electrons, and that was really Einstein. That's what Einstein won the Nobel Prize for. It wasn't relativity, it was understanding what he called the photoelectric effect, and that was in 1905. 50 years later, Bell Labs in New Jersey came out with the first efficient solar cell. That was in 1954. The day after that announcement, the New York Times had a front page article saying, energy source for the future is discovered and this will power our society in the future. And that was more than 60 years ago. The first application was a guy named Les Hoffman, worked in California, and he was using these tiny solar panels and putting them on radios. This was in the 1950s. At some point, in 1957, the Russians launched Sputnik and started the space race. And all of a sudden, all these resources went into the US space program to say, how do we catch up? One of the things they had to figure out was how to power the electrical transmission from the satellites back to ground. And so there was lead acid batteries, like car batteries you could use. Maybe you could use a small nuclear reactor up there. But the one that really won was a tiny solar panel. And that was in 1958, the first commercial solar cell. And so the US Navy was the first proponent of solar power. Solar has its day for a couple of years, but then other things ensue, and it goes in the background for a while. Until 1973, in October 1973, there was the Arab oil embargo. So the Arab states were at war with Israel, and the Arab states, OPEC, agreed to stop selling oil to the US, to Japan, to Canada, UK, and the Netherlands. And so all of a sudden there was a strong sense that we need to do something about energy, which had never been a policy area before. A lot of that focus was on synthetic fuels, like taking coal and turning that into a liquid fuel. A lot of money went into nuclear energy in the 70s. And a little bit of that went into solar, but there was so much emphasis on it that it was a huge change for solar. And so we had about $1 billion of research and development go in the 1970s. And that money accomplished some things, so to increase the efficiency of solar panels by maybe a factor of 2. But really importantly, it pulled people into the industry. So you had people in the electronics industry. There's this one guy named Paul Maycock who went from Texas Instruments building calculators and started working in the solar industry. And he said, you know, when we were in the 60s at Texas Instruments, we figured out that the more calculators we build, the cost would go down. It was called learning by doing, and he came up with this notion of the learning curve. And that's been a feature of solar ever since then. And there were a lot of policies that were designed to say that if we could subsidize solar, we could get the cost to come down by adopting it, learning how to produce it more cheaply. And that was a really important attribute of solar. And a lot of the subsidy programs that became important for solar, these were ended up being expensive subsidies, but it wasn't necessarily just to get solar installed so that we have employment benefits or pollution benefits. It was to get the technology to scale up so that you could get the costs out and have the costs come down over time. And that was really successful, first in Japan, which started a rooftop solar program, and later in Germany, which really combined two aspects. It took a California program, which guaranteed electricity prices from electricity you produce for 10 years, and the Japanese program, which subsidized rooftop solar, and they put them together, and in 2000 came up with this renewable energy law and spent $200 billion over 10 years on subsidizing renewable energy. And that ended up being about $25 per household for German electricity consumers to subsidize solar. That was probably the biggest event that led to the cheap solar we had today. And again, it wasn't just that we install lots of solar and had a lot of benefits come from that. Is that it created this sense of demand, and it led to investment, and it led to companies designing specialized material or specialized equipment to produce solar panels, not just take machines from the computer industry. We're now having solar-specific machines. It led the Chinese to take solar seriously and start producing for the German market. And then it led to this financing mechanism, this is the most international part of it all. So the German market, it was German residential energy consumers that were paying this extra $20 a month to subsidize solar in Germany. The Chinese were producing solar to sell to the Germans. The Chinese were buying equipment from the Swiss to make those solar panels in China. The money that the Chinese were using to buy those machines from Switzerland was coming from US pension funds because these Chinese companies had gone public on the New York Stock Exchange between 2004 and 2007, and that money was really coming from retirement funds that were investing and seeking return, and that was leading to these this Chinese scale-up that happened. And that Chinese activity between 2000 and 2009, there's kind of two periods of the Chinese story that I go into in the book. The second part has a lot of subsidies coming from the government, but the first part from 2000 to 2009 is wildly entrepreneurial, super competitive. No Chinese companies ever had more than 5% of world market share. And when the US was leading, they had companies with 25 or 30%. Japanese had the largest at 35%. Chinese companies were extremely competitive with each other, trying to get the costs out, and very scrappy, going around the world, finding secondhand equipment and putting it together. And that led to the substantial cost reductions in the last 10 years. And so one of the interviewees that talked about the solar program in Germany, where people are paying $20 extra a month, there were people that questioned it and said, well, what was the point of spending $200 billion on all this solar if it's all being produced in China? And there's a bunch of justifications, but one is what was our gift to the world. And that was, the gift to the world was scaling up solar. And then on the other hand, there's a sense that in a way, China subsidizing that even more was China's gift to the world, because now we're talking about in sunny places having access to really inexpensive solar power, probably the cheapest form of electricity that humans have ever made at scale, and then being able to produce that in a big way. And so that's China's gift to the world. And so, yeah, now we're trying to put it all together and thinking about how we apply this to other technologies. And that's kind of where my research is going now, is taking those lessons, seeing what worked. Okay, we can apply that to some technologies, and some are just different. If it's large scale, like large nuclear power plants, that's just a different way. You have to worry about system integration and getting things right the first time. But if it's something that's small and iterative, then you have a lot of chances to learn. And if there are technologies that look like that, that's the solar story, then there's a lot to learn from solar. And the big difference I would compare is if we think in the history of the world, we've produced less than 1,000 nuclear power plants. If we think about the solar industry, we've produced 2 billion solar panels. So that's 1 million times more chances to learn, to figure out what worked, to figure out what didn't work, to improve the processes, to get the costs out. There's that sense of iteration and improving things over time that's been so crucial to solar. It looks a lot like making batteries for electric vehicles, and there could be other technologies in the future that look like that as well. But finally, the challenge would be, how do you do it all faster? Because we don't want to wait 60 or 70 years like we had to wait for solar to do the next thing. So that's where the research is going. So happy to take questions. I have a few of the copies of these books, so if anyone's interested, happy to pass these out at the end. And yeah. Okay. Yeah. Well, you can judge that.
All right, just a quick reminder to hold the mic right up to your mouth when you ask a question, and it's ready to go.
Okay. We have some questions.
I'm just curious, would you recommend, with no liability to you, any of our small money that we could invest in that would support that world renewable in solar?
Yeah, I mean, the niche that seems kind of interesting to me in place, so if you're in a sunny place, like it makes a lot of sense to immediately put solar on your roof. It would just save money, and there's a lot of benefits come from it. There's the niche that seems to work pretty well, especially in Minnesota, and it's just starting to start in Wisconsin, is called community solar, where you get like 10 or 20 or 100 households to work together to build and fund a system as a community, and that gets the cost out a lot. And so in a place where it isn't quite as sunny like around here, that's a really good way to go. And I think looking at what's happening in Minnesota, where a lot of community solar projects have happened, is probably a good way to go. So.
Question here.
What is the typical payback as far as if you put solar panels on a typical house, or how far what would be the payback?
Yeah, so that's a good question. So I don't have a straight answer to you, sorry. So a few things that affect that. So one is the costs have been going down, so the payback is getting shorter. And then two, if you're talking about payback, that really depends on your bill savings, and that depends a lot on the electric rate that you have and how much energy you have and how much you can sell back to the grid. So that's when we're starting to take into account. But I had it scoped out for my house, and it looked like 6 or 7 years. And in that case, with that particular rate structure, with a big tree blocking the panel, which wouldn't have been that great. So, but that's the type of thing we're doing. But one thing that one point that your question emerges is it's not just the solar getting cheaper that matters, it's how electric rates work. And that, I really point people to the Wisconsin Public Service Commission in Madison, has 3 people that more than anyone else affect the energy future of the state. And they're appointed by the governor every 2 years, so you tend to get a mix of different parties on that panel. And 2 of them have to agree to support a change in the rates that might hurt solar or favor solar or lead to some other outcome and incentive. And so I think a lot of people don't appreciate how much power is in the hand of 2 people and affecting decisions that may be made today but affect the future of the state in 10, 20 years. And so electric rates that people pay are decided by those commissioners, and that's really an important area. So I think that's kind of a hidden source of maybe change or incentives. Yeah.
We have a question online.
Many confine the discussion to energy source, but distribution is a greater issue, having energy where it is needed, aka portability of electricity for application to private transportation. Can you speak to this?
Yeah, so I'll try to pick up a few things on that. Yeah, so one thing that I appreciate more than ever is that when we say an energy system is not a throwaway word. That's a really important part of it. So the supply of energy and having access to cheap, clean, reliable energy is important, but it's only part of the issue. And there's moving the electricity around with transmission, distributing it locally with the small wires and cans you see around places, and then starting to change the grid so that you might have storage on the grid that we're starting to see, change people's behavior maybe so that they might be responsive to when electricity is really inexpensive, like on a windy and a sunny day, or maybe more expensive when there's a lot of demand, and having demand be responsive to that. So having more renewables on the grid, which has benefits, also depends on having transmission, distribution, some storage, and then customers that are responding to the way energy is produced. So I think that's what I tried to get from that question.
We have a question back here.
Okay, couple things. I think I'm right under a speaker. So, in your view, is solar the answer, quote unquote, or should we be looking for a mix of green energies to supply our grid? That's part one.
That's a good question. So yeah, solar is a answer. It's becoming a bigger part of the overall answer than I think I would have guessed 5 or 10 years ago. Like, you can do a lot with solar, and people see maybe in 20 years doing 50% of electricity for the whole world with solar, but it's certainly not the only answer, and we need to be working on other things too. Wind seems to be important too. Nuclear power, it needs to be safe and reliable and do something with the waste, but that's within sight as well. There may be ways to burn fossil fuels but not have the CO2 go into the atmosphere. So yeah, diverse portfolio is the world I work in. But I have to say that solar looks like a bigger part of a portfolio than it used to.
And then one last quick thing. In your view, are programs like Wisconsin Public Services, NatureWise, and the company Arcadia Power worthwhile things the public can invest in to kind of move the ball a little bit?
I don't know the details of those, so maybe summarize for everyone what
I think you get NatureWise. It costs you like $2.50 extra per bill, and WPS states that they will source your power. I don't know how they do it, but they source your power from biofuels and wind. Mm-hmm. And Arcadia is similar. You work through Wisconsin Public Service to buy that service, but it's the same sort of deal.
Yeah. So, I mean, the idea is that you'll stimulate more demand for renewables, and that'll lead to more construction of renewables and a cleaner grid. The traditional, or maybe older, complaint about that is that, well, your power is going to be greener and everyone else's power is going to be less green because you're just shifting it. But that's actually gotten a lot more cleaned up in terms of making sure that any new power is additional and it's not just taking away from other people's greenness. So yeah, I mean, those things can make a difference. It's a lot of levers to pull to make this all happen, and that one is one to push on as well.
Another question back here.
Hi. I'm just wondering, you talk about it taking 50 to 70 years for energy change, and it appears that like coal and oil and all of those areas have so much monetary value in certain communities, and I'm wondering how much that has an issue in it. But my second question to that is because solar and energy are both like they're all over the place. How much is that energy history paralleling what's now going on with the solar history? Does anybody ever see that?
Okay, yeah. So on your first one about, there's tremendous wealth that's derived from having access to fossil fuels, like Saudi Aramco just went public a couple weeks ago and is the most valuable company in the world at $2 trillion. So people still think oil is worth a lot. But some of that is starting to change quite quickly. And if oil demand, instead of keeping growing, flattens or even starts to shrink because cars become more efficient or because electric vehicles really start to become adopted, a little bit of change can catalyze a lot bigger change, especially in terms of investment, in terms of new oil refineries and developing new sources of that. So I do see something like that as potentially something that could change pretty quickly, mainly because a lot of those big investments, depending on expectations, and if you hear what kind of bankers are talking about and investment analysts, they're starting to see some fossil fuels as potentially really risky, maybe because electric vehicles take off and demand slows a bit, but also this idea of what's sometimes called social license to operate, is that some of these companies may not just be in favor kind of politically as they have been in the past, and maybe even the communities may not want to go with them in the past, which may make them harder to sustain. And then finally, in terms of communities benefiting, there are issues with that. Like if we have a coal power plant that shuts down in a community, that hurts tax revenue for that community and it hurts employment in that community. But you do need to look at it in the bigger picture. And if you think about how many coal mining jobs there are in the US, it's been declining since 1920. So that's 100 years of decline. And we're now at something like 85,000 jobs. And there are about 30,000 solar jobs added last year. And there's about 300,000 solar installer jobs. And so what used to be kind of a green hippie thing with a few jobs that come out of people being especially interested in it is now like an important global industry and a pretty big source of employment. And so certainly those impacts, as you maybe hinted at, are not evenly distributed. So that, if a coal plant shuts down in a community and there's 100 or 200 people out of work, maybe that gets made up for more generally. But in the big picture, we really are seeing more jobs added in clean than we are seeing taken away in dirty.
Another question back here.
Yeah.
Could I just ask that that is, I'm wondering if energy did the same, electricity did the same thing back in the day of Thomas Edison.
So
Because
instead of
solar,
people doing horses or something and you have
Yeah.
electricity or
there a
motor
parallel?
vehicle. Yeah, I mean, these are, big social changes, and they can be, one thing that I've become more and more aware of and I guess concerned about too is how much employment there is in the automotive industry that has to do with maintenance and repair. And that's something where if you have electric vehicles, you have far lower maintenance and repair, which is great for consumers. Consumers are going to love that of electric vehicles, but it's not great for mechanics and repair shops and even parts suppliers too. Like they don't need transmissions. That's leads to a lot. So yeah, there's disruption that comes from some of these changes as well that needs to be taken seriously, for sure.
So I have a question back here.
Yeah.
So the sun doesn't shine 24 hours a day, right? and that seems to suggest that storage is a critical factor. And that comes to mind, I think, of batteries. and we're probably all carrying a couple in our pocket right now. So is that a driver right now? Better batteries would push solar dramatically?
Absolutely, yeah. Yep, batteries are huge, and they've come down in costs a lot. And I think, in 3 or 4 or 5 years, someone's going to have to write how batteries became cheap. And maybe I'll do it if no one does it by 2025. I think it's a little early, though, because we want to still see how it all pans out and where things go. And, a lot of it, as you suggest, comes from spillovers from phones and consumer electronics and laptops and the stuff we're talking about in cars, but also on the grid now are really mostly just stacked versions of these tiny batteries that are used for mobile electronics. But that doesn't have to stay that way. And so we could be talking about batteries that are designed that don't have to move around, that don't have to be compact, that you could get some economies of scale in doing in a big way. So yeah, batteries enable solar for exactly the reason that you're talking about. They're becoming cheaper, and this charge is lasting longer. And so, now we're talking about utilities buying battery storage for 4 to 6 hours. But if we could get more than that, and maybe have some storage that goes longer than that, that would really enable getting over this issue of intermittence, that it's not sunny all the time and at night.
Another question here?
Yeah.
How are the hardware manufacturers adopting the changes with the green energy? You've mentioned about autos, and not to mention the ubiquitous displays that we're having these days.
So what type of manufacturing are you?
Like hardware manufacturing for all the devices, like to make it like integrated with the system. Compatible.
Yeah, I mean, I think in some ways it seems like it's a missed opportunity that they're not using solar for some of this manufacturing. But on the other hand, if you look at utilities in Wisconsin that are saying we're going to have 50% or more than that renewables in the next 20 to 30 years. And one thing I've tried to do is say, why are you doing that? There's no federal policy that says you have to do that. There's a state target that says we would like to do that, but it's not anything that they're going to be held accountable for in the near term. And so as I've talked to people in utilities, one of the reasons that it's become stronger, I keep hearing, is that but our customers want that. Our customers want green power, and that might be residential customers, but it could also be data centers, and it could eventually be manufacturers that say, our customers like it that we say all our electricity is renewable or it's all clean. And so that's leading to some of the change as well. And so it's large companies, like the biggest purchaser of renewable energy now is Google for their data centers, and that's driving utilities to say, look, if we want to potentially serve these important customers, we need to clean up our electricity mix. So it's interesting that in a way it's kind of perceptions of what consumers want that's leading to the change. It's not policy coming that's driving it.
Another question right here.
Yep.
Since 3 Mile Island and Fukushima, nuclear energy has been branded as bad and terrible. And from my understanding, it's quite great, and some people think it's better than solar. Do we need to refocus our energy on nuclear energy as you were talking about before, as a collaboration with solar energy as well?
Yeah, so there's potential that nuclear works really well with renewables, because if it's dark or it's night or it's cloudy, you can ramp up nuclear power, and they're both very clean. And so, yeah, that's definitely potential there. And you mentioned these, what we sometimes call focusing events, big disasters that lead countries to move away from nuclear power. So Japan's moving away from nuclear power. Germany's going to get rid of all its nuclear power. There's other countries that are building more. So China's building more. There's countries in the Middle East that are building nuclear power. Korea's doing a lot. So there is a bit of a mix. But there are issues with nuclear power. So one is just to be explicit about them. So one is accidents. So you mentioned some accidents. So that's one thing people worry about. Another is proliferation. So there is potential that the fuel that's used in nuclear power could be used to run a dirty bomb, or could be enriched to make a real nuclear weapon, and so that's a concern too. The waste. So the waste from nuclear power, it's very compact. We know how much there is, but it's radioactive for a really long time, and so we don't really have a system to do that. So all the nuclear waste we've produced in the last 60 years is next to the plants where it was produced. And then finally, this is the most important issue, is it's just so expensive. Like to build a new nuclear power plant, people have tried doing it, and they're in the tens of billions of dollars, like between $6 and $20 billion for a nuclear power plant. And the other part of the cost issue is that they're really big. So it's hard to do a small nuclear power plant. And I have to say, that's one of the things that's made solar work pretty well and develop over this long period of time. It can work at any scale. And it's a factor of 1 billion from the smallest solar power plant, which might be on a watch or a calculator, and the biggest, which is in Egypt right now. And every scale in between has been used. For oil rigs, it was used for telecom repeater stations, people's houses, utility scale. There's so many different niche markets that you could serve, and nuclear's problem is it's only gigantic, and you have to be willing to put $10 billion in to start. There's been an effort, and that's one thing I look at in the book, is to do small nuclear power, called small modular reactors or micro reactors even, where you could maybe take advantage of some of the economies of scale that we've seen in mass production, like with batteries and maybe with solar. We'll see what happens with that. The one issue is that, okay, even if you do this manufacturing in a large scale and get smart about doing lots and lots of units, you still have to make them safe. And safe means something different. So if you make a bad solar panel and you've got 10 on your roof and one of them is out, you can get the warranty and have it replaced. If you make a bad nuclear reactor, it's a much bigger problem. And that really is something that solar's been able to ride on, is that they can work with maybe 90% perfection. With nuclear, you need much, much higher numbers. So yeah, it's a mixed bag. But I continue to keep my eye on it because it could, in the longer term, it could be something important.
Another call, question over here.
Yeah. Hi.
Over the years, I've been a proponent of solar. I lived in an off-grid home for a while, and when I first did that, there was a great feedback. I got a lot of money back for putting in solar. Recently, I've been driving hybrid cars, and I don't know if anybody else here has a hybrid car, but I was a little sticker shocked when I went to register it, and it almost doubled in Wisconsin to have a hybrid car over a non-hybrid car. So my question is, what kind of impact does policy have on people buying into different green energies when you turn around and you get penalized monetarily for doing something more energy conservation?
Yeah, policy is really important because, as I've kind of talked about a bit, there's a lot of benefits that accrue to other people by one person working and investing in clean energy. So you clean up air pollution, deal with climate change, reduce price volatility and macroeconomic shocks. There's a lot of reasons you'd want policy to favor renewables. And yet we often have these seem like counterintuitive issues where, because of the way that our highways are funded with gasoline taxes, we say, okay, these cars, hybrids are going to use less gasoline, electric vehicles are going to use zero gasoline, so how are we going to pay for our road repairs if we're not going to get it, if gasoline consumption starts going down because of that? And so you really need to make a bigger change, acknowledge that maybe gasoline tax is not the way you pay for highways, you need something else, because you don't want to end up in that situation where you're penalizing people from making an investment that creates social benefits. You want to encourage that. So yeah, that's a good problem to highlight.
Question online.
I actually have two, but they're related, so I'm
Okay.
going to throw them both at
All right.
you. Have you evaluated the total life cycle cost of solar? For example, the cost of total energy produced over the life of the array and associated environmental impact. And the other question is, the cost figures you did quote included government subsidy. When will it be free of funding from non-users?
Okay. So let's see. The first one is about the life cycle cost. Yeah.
Yes.
So there are some costs of solar that aren't associated with just the production of solar panels. So you need to recycle them, do something about them at the end of 20 years. And right now, that isn't a cost that's included in that. So that's something that manufacturers are starting to get smart on. So that's something that'll be an issue, say, in 15 years once the real growth we've had in the last 5 years starts to end of life and we need to do something about it. My understanding, though, is that there are a lot of valuable materials in solar panels that will make recycling worthwhile. Almost the only thing you can't recycle is some of the plastic that's in between the layers that are sandwiched together. But the glass is easily recyclable, the silicon is easily heated up and recyclable, and the aluminum wires are valuable and thus easy to recycle with some processing. So that's one part of it, recycling. The other part is that where are you getting the energy from to melt silicon and create crystals from it? So that's a real energy cost. And if you're doing it in Wuxi, China, where I went, where a lot of the manufacturing is happening, a lot of that electricity is coming from the Three Gorges Dam, which is pretty clean. But there are other parts of China and other times of the year when a lot of that would come from coal, and that's pretty dirty energy. But if you look at it over the life of, say, 20 years, which is what a solar panel is guaranteed for, that's a small blip, the amount of energy that goes into manufacturing it, compared to the energy that gets offset that doesn't have to be produced from oil or coal or gas from that solar panel. So it ends up being an interesting, and maybe the other word for it is complicated, combination of what the energy was you used to make the solar panel and the energy you're using to displace. And the very worst case is coal power generation making panels in China and then putting them in Seattle where it's not super sunny and all the electricity comes from hydropower anyway. That probably is kind of a loser in terms of overall savings. But if you go somewhere like Wisconsin where we're 50% coal electricity, and even though it's not the sunniest place in the world, it's still a much better bet to have solar there than to be burning coal in terms of the overall energy cost. So, yeah. The government subsidy. Yeah, I mean, these costs that I do in the book, I get rid of the subsidies. So I only look at, what's the real cost without the subsidy and look at that. And that's where we're talking about in the cheapest contracts now are like $17 or $18 per megawatt hour. And that's kind of a wonky jargony term, a megawatt hour. But it means something real. It's the average electricity consumption for a resident in the US is 1 megawatt hour per month. So you can kind of say if electricity bills are about $100 on average per household per month, the cheapest solar in the world, not in Wisconsin, like in Chile or in a really sunny place, is like $18. So 18 instead of $100. And so that's without subsidies. So that's where we're talking about. That's really the cheapest electricity that humans have probably ever made. And then so if you start to say, well, what about Wisconsin? All right, so a factor of 2 less sunlight. So that makes it twice as expensive, so maybe $40. And okay, yeah, I mean, we need to do something at night, so we need to pay storage as well. And those add maybe another $10 or $20. But, there we're talking about like $50 or $60, which is beating coal and not quite below natural gas. But if prices go down or if gas prices go up, they're pretty close. So wind, solar, and natural gas are all really close to each other in the U.S. right now in terms of cost, and that's about the share of each new capacity that's being built. There's no coal being built in the U.S. now. It's all wind, natural gas, and solar. Yep. Yep.
So everything you're saying sounds really great, and it gets me all excited, like, okay, let's start implementing this stuff. And so my question to you is there an ideal place? I'm from western part of the state where it's a tiny little farm town, and we had a small solar field put up, and everyone was all enraged because that's valuable farmland,
Mm-hmm.
So is there an ideal places for this kind of thing? Are we looking more at cities? I'm seeing things on Facebook that are saying, oh, we made solar panels that look like windows. You can see through them. So what's the projection?
Yeah, that's a good question. So I guess one is there's lots of different applications. So yeah, that could be. Yeah. But putting solar is now getting to the point where it's cheap enough that you could think about it as not like just putting it exactly the optimal place, which would be a panel directly pointed toward the sun, but put it on the side of a building because it's cheap enough. Or maybe put it on a car. If you put it on a car, you might add a few $100s to the price of a car, of an electric vehicle, and you give it about an extra 10 or 20 miles. So it's enough to like get home from the office if you don't charge it. So that's an application we could talk about. Farmland, that's an issue that comes up every time I give a talk about solar. It comes up, and it's a tricky one. We have some of the most productive farmland in the world here, and so covering it with solar panels doesn't seem like a great idea. On the other hand, if you're a farmer, to be able to diversify your income and not have to be at the mercy of agricultural markets or of buyers of your soybeans or whatever, but be able to say, well, I can play in these commodity markets, but I can also be selling electricity. That diversification can be pretty valuable. And the other point that's been made, I'm not sure I buy the argument, but I'm not sure on its own it's enough, is to say, after 20 years, you can move those panels somewhere else, or maybe you move them after 10 years, and maybe that soil has regenerated in a way that it would have been depleted if you'd just been taking crops out every year. So there's a bunch of reasons why we wouldn't want to cover all our farmland with solar, but some probably does make some sense, and so there's some arguments for that. But yeah, that's a key question to raise.
We've got a question back here.
Yeah.
I have a comment related to that. As I drive up and down the highways and I see the frontage roads and the space in between, there's all sorts of space. Oftentimes the power line is right there to plug into. Yeah. I think we should be putting solar panels there. And maybe on the power lines through the woods, there's places.
That's a great point. Yeah, there's lots of space that's not very valuable, or it's not being used for other things that solar wouldn't disrupt. So yeah, that's a really good point.
Okay, hang on. We have a question.
Do you have a go-to source for products, new technologies that you consult or could recommend?
On solar? Yeah. I don't. And I think that's one study that I've done a bit of, is that's missing. It's really hard to get the price of a solar system. I've tried to do it twice, once about 5 years ago and once about a year ago, and it's gotten better, but it took a long time to get one price. And one thing that we've noticed in looking at some of the data is solar prices vary a lot, and it's what's called price discrimination, and we actually need more access to information about solar, and there's a company called Energy Sage that's doing that, where you put in your address and you put in your electricity bill. And those two pieces of information, they will put that information out to potential suppliers of solar and give you bids. And you could have 3 bids just on that information, because they can use satellite pictures to look at your roof to figure out the slope of your roof and how much sunlight you'd get. So things like Energy Sage, it allows people to make better choices quickly and without a lot of effort, I think is really helping a lot. But we need more of that. Right now we're talking about there's too many markets where there's just one supplier and it's hard to get a good deal. So that, I think, will help a lot. And it's starting to change, but could do better.
Another question back here?
Yeah. I think it's fair to call you sort of a Silicon Valley expat.
Okay.
What about that culture served as an impedance to the development of energy innovation, since they're so fixated on innovating?
Yeah, that's a great question. I think stuff takes longer in energy. So the solar story took 70 years to pan out. There's a lot of regulation and policy, like that's come up in several of the questions, like whether subsidies are there, but also what the rates are. These people sitting on the Public Service Commission that serve with the governor's choice. The Silicon Valley people tend to be pretty libertarian. They don't want to have to deal with policy or to worry about policy changing. And when I was out there, I was interviewing venture capitalists, and I was trying to start to come up with this idea that they had this risk model in mind with energy technologies, where they'd say, well, there's a policy, it might get changed, so maybe we'll risk adjust it and say we'll only get 50% of the benefit, we'll count that much. And so I was explaining this to one of the venture capitalists, and he said, it's way simpler than that. He's like, what the government giveth, it can taketh away, and we value policy at 0. These technologies have to pay off on their own, and if there's anything that pays off only with policy, we won't invest in it. And if there's a policy that does benefit it, that's considered a windfall, but these technologies have to make money without government. And I think that sentiment doesn't really work with technologies where so much of the benefit is social. It's beyond the individual. It's kids not going to the hospital and have better health outcomes because we've got more renewables. And that type of stuff you need policy to really capture and value. So I think that's a big part of it. And the other is that other things just take so quick to pay off. Like if you come up with a new social media platform, 10 people with an idea that really takes off can make a lot of money, whereas with energy technologies, you usually have to build prototypes, you have to do manufacturing, it takes a while to start adopting it, and they're just not wired to think in years and decades, need things faster. So yeah, I think that's part of it. Hopefully they'll change, or maybe some other place will get more creative.
We have a question that came in from the library.
Good.
What does it do to your house insurance when you put silicon and glass and other materials involved with solar panels that could be detrimental to the structure of the house?
That's a good question. I would have to ask one of my solar install people to get at that one. I don't think that is an issue in terms of insurance. I mean, there have been some studies that have looked at house values that have solar, and there is higher appraisals for houses that have solar. So there's some sense that if you sell your house that has solar on it, the person who buys it will actually value that. And so it seems to suggest it's not seen as a liability, but seen as an asset. So that's where I come from.
Question back here?
Can you speak to the physics of solar cells? Is it about as good as it's going to get, or would significant improvements further reduce the cost of solar?
Yeah, I mean, I'll try to. So I don't work on that part. I presented this kind of discussion at a symposium at the University of Toronto about a month ago, and it was all material scientists and physicists, and their world is way smaller than mine in a way, but more focused, and smaller in the sense of looking at really thin layers that you could put on top of a silicon solar cell to get a few more efficiency points of it. So now we're talking about commercial cells that are 22% efficient. So 22% of the light that hits a cell comes out as electricity. But they're talking about getting up to 30% or something. And if you increase efficiency by 50%, that reduces the cost by 50% too. And so, we're not talking about increasing efficiency by a factor of 100 or something, but you could reduce the cost by half by doing, they're called perovskites, these thin layers that could absorb different wavelengths on the top, and maybe on the back of the cell do something at a different wavelength called quantum dots, and you put them all together, and you could get a 30% cell maybe instead of a 20% cell. So, there's some benefit to doing that, and that would make a big difference.
Question back here?
Could you comment on how policy develops over time and if we get trapped in certain policy interventions? I feel that we're trapped with gas, alcohol, whether it's a good idea or not, simply because of the infrastructure that's now been developed. We'll be in the same boat with solar in the future?
Yeah.
And is that a good thing, or should we have policy in the beginning to prevent legacy going forward?
Yeah, that's a great question. So yeah, people sometimes talk about advocacy coalitions, and when we talked about that subsidy program in Germany that was really transformative to really modernizing the industry and making it an industrial process, not just an individual customized one, it was because there was a coalition of different political parties, but then beneficiaries like the installers, and then large manufacturers that thought they could benefit as well. And then crucially, a really clever thing that the Germans did that probably made this really work is they excluded large electricity consumers like energy-intensive manufacturing, steel producers didn't have to pay this equivalent of $20 a month that households paid. So in a lot of ways, it was really unfair. Like households had to pay, and these large companies didn't. But on the other hand, that was the bargain that made it work, and that's why we have a lot of solar going in Germany. And so that seems like a really good way to get things started. But I guess maybe what you're going with is, like, over time, does the solar lobby start to block other interventions that might come up, like new technologies that might even be better than solar or might compete with solar? Maybe it's advanced nuclear that has other attributes. And so, yeah, it's something to think about and be concerned about. But you do need to have, in every country that I've looked at, you needed to have some kind of advocacy coalition come together to get things started for a new technology that's considered risky, doesn't have a lot of large beneficiaries of it. At some point, though, you have to make sure that things are left open for other products to play as well. So yeah, it's a good topic to introduce.
Another question back here?
It seems to me that economics has a lot to do with this, for good, but it seems like, despite politics, things have been progressing. And your last question makes me think about cap and trade and whether or not you've seen that work in other countries and whether that has potential to push our market further toward green resources and renewables.
Yeah, okay, that's a good question. So one thing that's, this has been advocated by environmental economists for 40 years, actually started at University of Wisconsin PhD thesis in the 70s, was the idea that fossil fuels create a lot of damage, health impacts, other water quality issues, and that what we need to do is put a price on that damage. So if you emit CO2 or sulfur, you should pay a price. You shouldn't be able to put that in the atmosphere for free. And we've done that successfully to clean up acid rain. And then the idea is with cap and trade or carbon taxes is to do something similar for CO2. And so I still think that's a good idea and would help a lot. It would help to really shut down and clear out the really dirty technologies. But on the other hand, so that's kind of the economic viewpoint on it, the political scientist perspective says that if you look at every country that's ever put a price on carbon, they've always started by having subsidies for green power. And there really does seem to be something that's more politically palatable, and maybe it's not economically efficient, and maybe it's not entirely rational, but it's effective, which is that you start by supporting the green technologies, getting them going, get those advanced, made reliable, made kind of supported, and get the costs out, make them cheaper, and then you start pricing pollution, and at that point, you don't need as high a carbon price because the electric vehicles or the solar panels or the wind power or the storage has gotten cheap enough that it's not that painful, that you could do it where it adds a couple percent to someone's electricity bill, not 50%. So yeah, I think it could play an important role, but it's a lot easier to do it now and probably in a few years than it would have been 10 years ago when we had a bill that passed in the House of Representatives in the federal government.
Question here?
Yep.
I was just wondering, so up here, solar is a little bit less efficient, a little longer of a return. What are some things that people here could put on their homes or implement in their lifestyle to make a bigger impact, like right now?
Yeah, so solar is one thing. I mean, with homes, just the investments that you can make in efficiency, lighting is probably one that now is amazingly inexpensive. So it's really to the point now where it's environmentally beneficial to take perfectly functioning incandescent lights or perfectly functioning compact fluorescent light bulbs, little spiral ones, and actually dispose of them, that's actually better, and then replace them with LED lighting. I mean, for a long time you'd say, well, only replace it at the end of life, but now you're better just going through your house and replacing all. So lighting is one. You know, in this type of climate, insulation is big. And, you know, a lot of those investments, or a lot of those require upfront investment. So it's not always easy. It's not something you can do kind of incrementally with behavioral change. It's kind of a one-time thing. But, you know, those have, for a long time, have had big returns in terms of just private energy bill savings. And so those are good places to start because they have environmental benefits too.
Question online.
That's me. Okay, so we talked about nuclear reactors and the fission. Can you speak to or give us an update on the current state of fusion reactors?
No,
Okay.
but I wish I could, and I would like to. I mean, I do have colleagues at the University of Wisconsin-Madison that, like, I know close enough that I feel responsible by answering the question that way. But I do know they're working on it. And, you know, there's a big effort in Europe to build a large fusion reactor. So basically, fusion is basically what the sun does, where you take atoms instead of splitting them apart, which is what most nuclear reactors do, and get them to go together. So you have to put a lot of energy in to get these atoms to fuse together, but then they release so much energy when they combine that you get more out than you put in. But so far, it's been hard to do that on a real scale. But, you know, that could make a really big difference and potentially a really large energy source. But that's a research stage. That's not something we're talking about in the next 20 years, really. Yep.
In an effort to be optimistic, can we say that renewable energy, wind and solar, has been successful in shutting down coal-fired plants
It's a yes. I mean, I would say and cheap natural gas to be really clear about it. So having wind, solar, the idea that storage is available, and then having cheap natural gas. It's really hard for an existing coal power plant to compete with that. And that's an amazing thing to think about, is that we're not talking about, do I build a solar panel, do I build a solar plant or a new coal plant? It's like, do I run my existing coal plant? And more, the answer is no. It's too expensive for the labor and buying the coal and the utilities that are required to run that plant compared to setting up a new wind farm or a solar farm. And that's pretty amazing. But it's also cheap natural gas that's part of that too. But yeah, and it's not policy. Like there's not a policy that says we're trying to phase out natural gas or coal plants. There's not a policy that says power plants have to be below some emissions limit. There's not a policy that says those coal plants have to pay for the CO2. Those have all been proposed and have at certain times gotten far along, but none of them exist now. It's really just on the bare economics of, I'm an investor, I want a big return, I'm better off building gas, wind, or solar than I am running an existing coal plant, and no new. So we've seen no new coal plants built in the last 10 years and much retirement. So like 10% about of the US fleet's been retired. And that's not aged plants that we're going to get offline anyway. Some of them are only 20 or 30 years old and we're saying don't run them anymore. So yeah, I think that's a long answer to say yes to yours. Yeah.
Do you know anything about homemade solar cells? Are they worth it or not?
I don't know anything about that. Sounds really interesting. And
I found where the procedure of taking a glass and laying down different layers of stuff to build your own solar cell. I didn't know if it was worth it or not.
That's interesting. It's the first time I've heard of that. But I will say that, in doing this book and doing the research, that most of the technology is in the manufacturing process and the equipment that's used to do manufacturing at gigantic scale. But the actual cells themselves are not that complicated. And of course, the scale is household scale. So yeah, I wouldn't dismiss that at all. That sounds interesting.
Question here.
Yep.
So with like Tesla, talking about coming out with the shingles and everything, they're gonna be more affordable than normal. The solar shingles are gonna be more affordable than normal ones and everything. It's starting to become this really popular and mainstream idea for solar. So what would you say is the biggest obstacle currently for solar power, and how can we overcome that?
Yeah, that's a good question. So one obstacle, might be utility rates, and it's going back to these commissioners that are sitting on the west side of Madison. There's ways that those are designed that could be changed that could lead to better. So that's one, those incentives. Going back to the policy question, so if we had policies that led us to face the real costs, so like when a kid goes to the hospital because they've been breathing particulates from a fossil fuel power plant, there's cost to society of that health impact. And so, having fossil fuels pay that cost would make a real difference in getting there. I think there's also just some familiarity too. And for solar, as you mentioned the word mainstream, for that to become something that's not considered something you do only if you're green or if you're a hippie or if you're just technologically like super interested in it, it's something that's like, oh yeah, we want to save our energy bills for our house, or we want to find a way to have more revenues available for our school district. Maybe this is a way to cut our energy bills in the next 10 years. Those are the types of decisions that I think once those get more mainstream, you start to see things happen more quickly.
Question over here.
Yeah, I just had a comment. I'm thinking of a way to save the satellite TV industry. And with DirecTV and Dish TV, why couldn't we have a solar panel in the satellite dish? The wiring's there, and why don't we run it in the house? And we could provide enough electricity for each individual house.
That's a cool idea. And there is something to be said for that, there was this effort for a while to do these parabolic solar cells, which is basically a mirror So you cover your dish with a mirror and then have a very efficient solar cell where that little receiver is, so that you could be willing to pay a lot more for like a 30% efficient cell, but also you'd be getting like 200 suns worth of energy on that spot instead of one. So yeah, I haven't thought of that. That's interesting. Yeah. Yeah, let's do it. All right. Yeah.
A friend of mine up here is 83 years old. This summer, he put solar panels on his roof. So I hope his payback is really fast.
Yeah.
And I asked him just Monday, I had breakfast with him, and I asked him Monday how the solar panels were working out.
Yeah.
And I got two things for you. Number one, he said, well, a lot of cloudy days and a lot of snow this year. So
Yeah.
he's not getting any input, or payback from that at all. When he got the system put in, he had a company put it in that had done a lot of them. And along in the conversation with the contractor, he said, you know, what do we got to do? What's the steps in this? And the guy told him all about it. And he said, and then we got to have it certified after we're done. We found out the company that was doing the certification was the company that now serves him with electricity. This is in Price Electric area, which is called Pricey Electric by those of us
Yeah.
who have Price Electric.
Yeah.
Because they produce none of their own power. They buy it all for 19 counties. And they had to come out and certify that his solar setup was appropriate. Isn't that like kind of putting a fox in charge of the hen house?
Yeah, it seems like you'd want to have an independent third party doing that certification.
He couldn't do that.
Yeah, yeah. So that's an issue. Clouds are certainly an issue. Latitude's an issue. Night's an issue, and so that has to be something that's dealt with realistically at the beginning. And yeah, snow's an issue too, and that's something that is something that could be dealt with mechanically or with the angle of the panels, or having them installed at ground level, for instance. But that's something to take seriously too. That in this environment is real. Yeah, yeah. Great.
And
Yeah,
to Greg
thank you.
Nemeth.
Really
Thanks to
enjoyed
our
the questions.
sponsors. Yep.
Right.
Thanks to our sponsors, Monaco Public Library, Lakeland Badger Chapter of the Wisconsin Alumni Association, Kemp Natural Resources Station, UW Trout Lake Station, and the brewery. And our funding, again, is from Brittingham Fund. Next Science on Tap, February 5th with Dan Preston, talking about the conservation of our freshwater ecosystems. And if you'd like to be on our email list and are not, you can sign up in the back. Thank you.